So in today's lesson, we're going to talk about graphing equations that are given to us in vertex form. So what I'm hoping is at the end of this lesson that you can say, I can draw a graph when I'm given the vertex form of the function. Now, first of all, if you haven't already got this memorized, I hope you've at least got it written down, because that is so important to know what a vertex form of the function looks like. So make sure you know that. I'm also suggesting there's basically 3 steps to doing what we're going to do. So first thing we're going to do is find the vertex from the equation. Then we're going to find the y-intercept from the equation. Then I'm going to call it a mirror point. Let's do a couple examples. So the first function I'm going to graph is this one. And what we should notice is that h is right there and k is right there. Okay? Really important that you check the sign right here, okay? You got to check that sign. So what I'm seeing is that h is positive 5 and k is positive 6. And I could write that as an ordered pair like this. So what that's saying is that if I went onto my graph, and I think these lines are going up by more than 5 or more than 1, but I'm going to go treat them as 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. That's where my vertex is, right there. Okay, so this is the location of my vertex. That was easy. Step 2, what we're going to do is find the y-intercept. So I'm going to take my equation, y equals 3 x minus 5 squared plus 6. And what do we know about things at the x-intercept? Well, at the x-intercept, x is 0 at the x-intercept. Okay, so what we're going to do is we're going to make our equation, we're going to make x equal to 0 and then solve. So y equals 3, and we're going to put a 0 there, because that's my x-intercept. 5 squared plus 6. So now what I have is I have y equals 3 times negative 5 squared plus 6. So y equals negative 3. Let's see, negative 5 squared is 25 plus 6. Make sure we follow all the order of operation rules here. So that's going to be 75 plus 6. Y equals, 81. And you're going to see that my graph, if I was to draw the 81, it's going to be right off my page. So obviously, I'm going to have to do it to scale. And because of this, usually the question is going to say sketch. We could draw a perfect graph, but usually what I'm going to be looking for is a sketch. Okay, but let's just for fun say that there is my y-intercept up here at 81. Do that in green. Okay. And I'm going to call it a mirror point. This is referred to where I have my vertex. This is known as an axis of symmetry. And we mentioned before that these functions are equal on both sides. So if I have a dot here at 81, I also have a dot over here that's up 81 from my x-axis. Okay? And so now the question is how far over is it? Well, I know that this was over 5. That's 5. So therefore, this must also be over 5. So how far over is it? It's over 10. Okay, if that's over 5 and that's over 5, then it's over 10. So the coordinates of that point right there, to the coordinates in green, the coordinates here would be 10, 81, and this one would be 0, 81. And we have our axes here, our axes. Well, I can write the equation of the axes. Let's make that stand out both black. The axes is x equals 5. Every time you write an equation which is what that line is as an equation, x equals 5. Okay, I've done it in dashed line not to confuse with what we're doing. I was writing the coordinates, so this was at 5, 6, which we found first. And now I have 3 points. So I have a pretty good idea that my graph is going to come down, my function is going to come down like this, hit that point, and it's going to go back up through that. And we got to remember that this is going to keep going indefinitely forever. Let's do a second one. Once again, sketch -2, x plus 6 squared, take away 3. Once again, we got to be really careful about sign. And because that's a positive, I know that my h is -6, okay? So basically when it's inside the brackets here, it's the opposite of whatever that sign is. My k here is -3. So once again, if I was to graph this, -6, 1, 2, 3, 4, 5, 6, 1, 2, 3, -3, right there. So there's my vertex. My vertex is at -6 and -3. And if I wanted my axes of symmetry, I could easily say that my axis of symmetry is at x equals -6. It's right here on that line. So somewhere up here is my mirror point, and everything on both sides is equal. I'll write this in blue. This is -6, -3. So second step, let's find my y-intercept. So I'm going to go y equals -2. I'm going to put a 0 for the x, plus 6 squared minus 3. Y equals 2 times 6 squared, take away 3. Y equals 2 times 36, take away 3. Y equals 72, take away 3. Y equals, what's that? 6, 9. Okay. And so the coordinates I'm looking for are 0, 6, 9. That is my y-intercept. Okay, so my y-intercept is going to be down here somewhere at 0, 69. And remember that I'm going to have on the other side, I'm going to have another one. Let's see if this, let's just put it in purple. This was over 6. So I'm going to go 6 more and put another dot right there. That's my mirror point. Okay, and so the coordinates of that one will be -12, 69. There we go. And now I sketch my graph. Remember, it's not a perfect graph. It's a sketch. Oops, through that point, going to keep going forever. And it's going to go through that point forever. Not quite symmetrical in my drawing, but that's a good enough sketch. Okay, once again, we're just sketching, not looking for a beautiful, beautiful graph. And then we can always double check our work by going to Desmos and putting in our original function, this one here, put in Desmos and see how we did. Good way to check your work.